This segment introduces the major functions working over lists that are in the prelude and in the list data module. The function that constructs lists, it's called cons. It's written as an infix colon. It constructs a list by adding an element to the front of an existing list. Now you can imagine every list can be constructed that way if you start with a empty list, and we'll build on that when we look at how to define functions over lists in the next block. But for the moment, cons is there as a function. You can use it, and you can see what I'm doing here is I'll introduce the type of the function and I'll show you an example. So here I'm showing 3 cons. The list 62 gives us a list 362. And the type of that is that it takes something of type A and something of type list of A, so an arbitrary element from the same type as the list type, and returns a list of that same type. Complementing that is the plus plus operation, which takes 2 lists and concatenates them together. You can see an example there with a string where I'm building the string ABBA from ab and ba. And note that that's a different type. Plus plus takes 2 lists and gives us a list. Cons takes an element and a list and gives us a list. One thing that we can do, and I introduced this earlier as well, we can select elements from a list, and that's using the pling pling, the exclamation mark operator, and that selects the element in the nth position starting at 0. So if we ask for element number 1 from the list 362, we get 6. Concatenation builds a list, and it builds that list from a list of lists. So here we've got, you can see in the example, we've got a list with 3 lists in it, the list 2-1, the empty list, and the list which is just 3 in. What that function does is join the lists all together into a single list. And you can imagine you can do that by putting plus plus between all the lists, as it were. That joins them into a single one. We can take the length of a list. That takes a list of arbitrary type and returns an integer. And we can take what's called the head of a list. So there we go from a list to an element, and that returns, if the list has a first element, it will return that first element. Otherwise, it will raise an error. Conversely, we can take the tail, which is what you get when you take off the head. So that's the list with the first element removed. So head and tail effectively reverse cons. If you con something onto the front of a list and then take the head and tail, you get the thing and the original list back. And here's a simple way of building a list. If given a number and an item, we build a list with that item repeated that number of times. So replicating 3, the character x, we get the string xxx. We can split lists up. I guess just stepping back from this, which I should have said at the beginning, but never mind. There are an awful lot of different things you can do with lists. They're a collection. We can join collections together. We can split them. We can take parts of them. And this is a function that takes a part of a list. It takes the first 3 elements here. So we have an integer and a list that takes the first 3 elements, and conversely drops the first 3 elements. Now, if I wanted to take 10 from the list wager, I would just get back the list wager itself. It can only take 5 elements. And similarly, if I wanted to drop 10 from the list, I would get the empty list. It can only drop 5 elements. So it will drop as many as possible in the case where the n is bigger than the length of the list. And there's a single function split at, which combines the results of the 2 and gives you a result as a pair. So here that splits the list at after 3 elements. So you get the front half and the back half as the 2 elements of that pair. There's a function to reverse the order of the list. In fact, we've seen that already when we looked at the examples earlier. What reverse does, it takes a list and just reverses the order of it. You can see it there applied to a string. I'm showing you examples on strings because they're easy to write and visual, but this works on, of course, works on any type of list at all. And then we have, as we did meet earlier, the zip function that takes two lists and zips together the corresponding elements in the two lists. So you can see here, if we've got the list 1, 2, 3 and 4, 5, 6, 7, we get back the list with a pair 1, 4, pair 2, 5 and pair 3, 6 in it. You can see there I've given a list of different lengths to zip. It will produce pairs for the shorter of the two lists, because you can then, everything in the shorter list has a corresponding value in the other one, but not necessarily vice versa. Here, the 7 at the end of the second list doesn't have a corresponding value. And of course, we can unzip a list of pairs into a pair of lists, and that necessarily, that will give you two lists of the same length there. So if we were to zip and then unzip, we would lose any unmatched elements from the end of one of the lists. And finally, we have some functions which operate over a specific type. So AND is a function that takes a list of booleans and returns their conjunction. It ANDs them all together. OR is a disjunction. It combines them all with OR. So AND of the list true false is false. OR of the list true false will be true. And similarly, we have sum and product, which give us the sum and product of numeric types. So for example, sum of the list 1.4 and 2.5 is 3.9. So that covers the major functions in the prelude, except for one or two that I want to single out for special attention in the next segment.